Here is the lecture on discrete time Fourier transform. As you can see here, there is a sample of a digital data, that is a discrete data. As you can say, that's discrete time Fourier transform. So we will analyze the Fourier transform with respect to the discrete time. As you can see here, there's a time in the discrete form. That means this number of samples are there, okay, and that's the signals right there. So when you get the equation of discrete time Fourier transform, that how you could transform uh, sample and a discrete signal to Fourier transform to make it x j x e j omega, x of the function of e j omega, right? So first of all, that is the synthesis, that how you could find out the xn as real data, and you will find out 1 by twice pi. The time length will be under the twice pi x of e to the power j omega. So that is a vital thing when you just in the time respect, when you convert the time domain to the frequency domain, you use this kind of e to the power j omega equations. That is really closer to the jet transform too. So Laplace, Fourier transform and jet transform are all aligned in the same criteria, but they have different type of operational tactics and computational methodologies, so it differs. So there are different type of purpose when we will use the Fourier transform, when we will use the Laplace transform, and when we will use the jet transform, right? So there is a synthesis type of equation. After the synthesis, you will find this. So that is the jet transformed value, the capital of x of e to the power j omega equal to summation minus infinity to plus infinity x of n e to the power minus j omega. So you can, so here you can see e to the power j omega n d omega. After converting that, you will get e to the power minus j omega n. There is no such use of integration here. Here you can see there is a use of summation here. Not practical for real time of computation on a digital computer. It's not practical. What is the solution? The limit the extent of the summation to n points and evaluate the continuous function of frequency n equispaced points. That means in integration that it might go to the infinity, but you can make it to the finite points with n point limit. So if you make the point to the n point limit summation and evaluate it, you can easily get the Fourier transform part. So here you can see x e to the power j omega, omega twice pi by n k, that is the number of points that you want to calculate or you want to sample, and that is the last formation of the equation of the limit type. You can say that is the discrete time. So whenever you find a Fourier transform of x of n, that is the sample, just make a Fourier transform ft. That's normal, that's not normal Fourier transform, there's a DFT, maybe discrete time Fourier transform, DTFT. You will get capital X of k, capital X of k. So what is the capital X of k or xk? That is n equal to 0 to n minus 1, and xn, here is xn, x of n, this number of sample values, and that is the main equation, e to the power minus j twice pi. You have to remember the total equation here to find out DFT of any kind of sequence. Kn, small letter n, divided by the capital N. Capital N is the number of points, okay? The smaller n will be the change of this index number x of n. As you can say, that's the thing, xn, that is the number of samples, right? E to the power minus j twice pi kn. What is the k? K is the each of the sample value of the Fourier transform, okay? and that is the number of points, and that is the exponential form. So if you use this particular equation, that is the n point DFT, that is known as n point DFT. N is equal to 0 to n minus 1, that means 4 point DFT will come along 0 to 3, 3 point DFT will come along 0 to 2. So each and every time, each and every part, your e to the power minus j twice by kn divided by n, this equation is same. You have to just make the indexing value xn there. So there are some MATLAB code for the DFT. You can use this kind of thing, that DFT x, and use this, create the size of the function, then just plot the function with like that, xk, k plus 1, x to the e to the power minus j twice by kn by n x, that's the function. So that is the MATLAB code for DFT. You can easily use the DFT code like that, DFTX. So that's the way. But in MATLAB, that is the FFT code, that is known as fast Fourier transform, and that has been used in various programs, FFT, IFFT, instead of using the DFT. So you are not been able to find out the real code of the DFT, right? So you have to make the function in light of the equation, that is xk is equal to n equal to 0 to n minus 1, capital N minus 1, x smaller than of n index e to the power minus j twice by kn divided by n. So the exponentials can be pre-computed so that the DFT can be computed vector matrix multiplication. Later we will exploit the symmetry properties of the exponential to speed up the computational, just like FFT, it's a fast Fourier transformation, and we will know the computational process. There are a lot of processes to compute this thing. So that is a given signal, that is a given example that how we could use the DFT, right? Discrete Fourier transform. So here is an example. Here is an example, that is a signal, that is x, that is 1 2 2 1. You have to calculate the DFT of the signal. How we can calculate it? So here is no arrow sign here in any kind of indexing. So the first digit will be indexed as 0. So x0 is equal to 1, x1 is equal to 2, x2 is equal to 2, x3 is equal to 1, and xn is equal to 0. So whenever you find out that x1, that's the 0 point, that is the first index, second index, and third index, right? So there are a lot of indexes are there. Whenever you find this, then you can easily find out and calculate it. The number of points, there are 4 points, 1 2 3 4, there are 4 points. Okay, so the number of points n is equal to 4. So now you can tell that xk, you will find out xk. So n is equal to 0 to n minus 1, capital N minus 1 means 4 minus 1, that is 3 here, as you can see, and that is xn, e to the power minus j twice by kn by 4, that means the n number of points, right? And the k value is also determined by it, that means k means n minus 1, that is 0 to 3, 0 1 2 3. So first of all you have to put the 0 value here, x0, x1, x2, x3. You can see the value of n changes, but not the value of k changes. The value of n changes, the value of n changes, the value of n changes, the value of n changes after and after. That is the basic equation. You have to find out xk first of all, okay? Then you can find each and every point for 0 1 2 3, okay? That is the basic point. Okay, so just replace the value. X0 is 1, x1 is 2, x2 is 2, x3 is 1. That's the thing. And the e to the power minus j value has been sorted out. You can see the calculation here in each line. You can see the calculation here in each line has been calculated. After that, after calculation of the whole system, you can now find out this equation. Why you will find out this equation? Now you will say it's more complex to us. So if you want to find out the things easily with respect to e to the power, you need not to do this. You just take this